the most modern technology to bring manufacturers into the digital age. Well, John, thank you so much for joining us for Control Automation Day. I'm really excited to speak with you today. I know we've got a lot on tap to talk about one of the big topics of today's world, which is AI, but more specifically, how it fits and how it works for control engineers. For most of these keynote conversations, we kind of get started with a little bit more background just so we can kind of get to know you and what your role is and how your journey kind of started, the educational background that you had that first got you down this path of automation, robotics, and industrial automation. So what does that path look like for you?
Well, let's go way back. I mean, it goes back to when I was 6 years old, and I methodically disassembled appliances, got light switches, light bulbs, motors, and things. I had a grandfather who ran a hardware store in Little Rock, Arkansas, and he was a contractor and built houses. And I rummaged through his stuff and disassembled some of my mom and dad's appliances and automated my bedroom where he'd open the door, turned on lights. At the time, it predated, even the Commodore PET or the TRS-R80. There were really no computers to be had. And so it was all switches and dials and lights and wires. And I grabbed 110 volts a couple of times, more than once, learning the hard way. And so that's kind of where it all started. It was just disassembling things and curiosity, and had a fairly normal school background. I didn't really make great grades, even though both my parents were school teachers. I really struggled with the point. And when I got through high school, I did some training at a local Botech, and that's where I got my exposure to basic circuit analysis. But that's where that started, is just curiosity.
A lot of what we're talking about today involves AI, just kind of making it more tangible and real. And could you just kind of briefly walk through those steps, kind of starting probably with the first one, especially when it comes to brownfield facilities? We hear a lot about AI being able to interpret what's going on, but that's easier said than done, I feel like, a lot of times. Providing AI with the right context, the right information, the right inputs to be able to evaluate, how does that work? When you're working with customers, how do you usually walk through that step of providing enough information that then the further steps, like providing tests and to develop new code to improve things, is viable in the workflow? So I'm kind of curious how that first step with the contextualizing really happens.
What we discover is that until we really have good data for the customer's own experts to use, there really isn't a handle for AI to get a hold of, right? It really comes down to the quality of data. Places where you have a good model. So if it's a safety critical system where you have to keep up with a lot of the variables to be used to validate safety. And of course, a lot of the IO is basic safety. You push the button and the whole site shuts down, and you better dang sure sure that it does, right? Because there are lives on the line. They have a little bit better chance because they've had to keep up with this data because of industry requirements, or sometimes even the law, right? If you're doing interstate transportation of hydrocarbons, you have to document these things. You have to test these things. You have to have records, which usually means you've got drawings, you've got specifications, you've kept all the paperwork for the original equipment. So even if it's very brownfield, you have ways to hook the data. And back to your question, that is the very first thing we look at. We look at this is what the customer wants to do. And then we go in and we look at what they have to do this, right? And I will say that it is very interesting. And I made this observation this morning, is that since we have LLMs now, and they're really used by pretty much everyone pretty much knows when we come in the door, we know we don't have the data we need to do this. Early on, in Kelvin days, just a few years ago, this was often a surprise that the data just wasn't there and it wasn't easily accessible. If you didn't really have the PLC project, there's really no way with older generations of PLCs to pull the project and then put it back in, because a lot of the details only set on the project on the PC. And now PLCs contain almost everything in the PLC. You can just upload it, right? It really comes down to data. And do you have the information in your system to feed a physical model. So in the Siemens world, this is where we'd use like AmSim, or one of the Sim Center tools. This is where we start to cross. And this is the thing that you see Siemens working on today. This is in the news or in, social media, you see the one tech company thing. This is where Siemens has realized that, hey, we're a great hardware company. We've made a lot of great products, but from a business perspective and from a customer's perspective, Siemens Digital Industries Factory Automation is a different company than Digital Industries Software, right? They are operated as different companies. They have a different HR system. They have a different non-HR system. They have a different IT system, right? And they have different business practices, right? They're different companies with their own goals. And so XD is designed to bridge that gap. So when we come in, we consider the whole portfolio as being one portfolio. And as a team, we deal with the differences between companies, and we coordinate with our team members at their respective companies to bring everybody together, right? And so my role is not a sales role, but in the XD team, we have a number of people who are experts cross these lines, and they're able to talk to customers. So a lot of times when we come in, this is understood that this is really a merging of two companies' technologies. And Roland's point, this is a very needed need. I know I kind of went around your question, but at the end of the day, it all boils down to data.
And it's a hard question, I think, to answer specifically because every situation is a bit different. So saying, what do you need to provide context? Well, that really depends exactly on the customer's application. Do you find that, since you said if the company, the data scientists of the company realize that they need more information, it's not a surprise to them, but it probably, I would imagine, goes along with hearing stories of a lot of facilities where the code has not been managed well and it's very disorganized. The hardware is very mix and match and disorganized. I'm sure that's more of a brownfield rather than greenfield kind of problem. So that's kind of the same answer. Dealing with those disorganized situations, really it's cleaning up the data, knowing what information you have access to, and making a scenario where the engineers are already comfortable with the data that's inflowing. And that sort of sets up the AI model to be able to deal with the data more properly.
That's correct. So at the end of the day, this is why you see a lot of efforts around, and you said something, I'll just back up. The company's data scientists, there are a lot of companies that even today don't have a data science department.
True.
Right. And so you're right. You have data scientists, they're pretty aware. I don't have the data, and I've been having to infer some of these things from historical records, which in no way line up with the sequence of operations in a process, right? They're not time indexed well enough to really coordinate them to what they're seeing in a process. So you've seen data scientists do some pretty creative things with, shift metrics, day metrics, week metrics, right? To kind of determine generally what's going on. They know there's an issue. If there's a data science department, we're in pretty good shape because one thing, they pretty much already know what's missing, right? And so it is that point we can attack getting that in. So it could be a process where we go in and we do an additive IO layer. So one of the things we would use would be Industrial Edge, Siemens Industrial Edge, where we could deploy up against these legacy machines the ability to collect data using their native protocols, right? So now if you have the data in the PLC, you can get it and it's pretty relevant, and you can make that event-driven transfer of that data to a database or to the data model, right? Backing up, when we talk about AI can infer things from large sets of data and give you some direction, but a lot of what we do is we model using a physics model, whether it's a mechanical model or a chemistry model, the actual process. And so we look at what the estimated output would be based upon real process values, right? The real win, and what I was getting to, is when you have that going on where you can see the deviation, where the machine, the LLM, understands the context completely. It can see the code. It can see the data. It understands by reading the model or the document of the chemical or mechanical model what it should be. It can infer some tremendous things, and I'll just leave it at this. The more context you can give an LLM, the better its answer is going to be. So Siemens has a relatively new product. I think it was released in one of the the trade shows in this season was called engine, right? The engine, right? And so it is a application that runs against the TIA portal openness, and TIA portal is the platform or the IDE for the Siemens automation platform. Drives, PLCs, HMIs. It's a unified IDE. It's very powerful. It's relatively complex, but it was for years has supported an openness, what they call the openness API, which lets you by function reach into portal and have it do things. They gave this engine tool, which is an agentic agent that runs in a container. It basically runs as there's a console for this agent to reach in, and it's able to leverage this openness platform. Now, the first time you use it, you've got to give it permissions to read files and do various things, and it's very, very discrete. So every function in openness has to be enabled, and it is per project. And this tool only looks at a specific project. It's not able to look around your drive. You say, hey, I have this project loaded. I want you to look at it. And each project is isolated to one project, which would be a PLC project, HMIs and drives, anything else is in it. If that project is built with structure, like say it's built with model type package or MTP, it can look at that and realize, oh, this uses MTP. And then it goes and it looks at documents for MTP implementation for the Siemens platform. And then it goes and it looks at the MTP standard for the organization that manages MTP. So now it has an expectation of what it should look like. Then it can really take off. It becomes pretty dang smart. It can tell you things that you did not know about the application, how it's organized. A lot of times, what I'll do is I'll use our example applications we have on CIOS. So the one thing that Siemens has through its industrial online support, or CIOS, right? I think it's now called SIA Portal. There are numbers of example applications for various PLCs and various technologies. And so when Siemens created the MTP implementation, which they used several libraries as standard function blocks for the programs, and then they inserted the ability for MTP to manage the functions of the program. MTP basically provides a standard interface for a process orchestration level, the level above the local HMI, like the plant-wide or enterprise-wide system. Its job is to reach through or past the local HMI and instruct the line to do things and orchestrate things centrally, right? The implementation of this properly documented in that program makes that LLM pretty smart. And you could say, hey, make me a function block in the style of this project, because it's so well documented. It will actually create you a function block, an MTP capable function block, because it has so much context. That is a roundabout way of answering your question is the more context the LLM has, the smarter it's going to get, because it is very broad understanding, right? It's not like what we keep hearing about are small language models where it is very, very technically specific. It doesn't know everything. In theory, that draws less tokens, right? So it's cheaper to run. We haven't seen those. They're coming. We should start to see some of those show up this year.
Rather than a lot of the way people use LLMs and AI applications now is by uploading choices of documentation, whether that's manuals or CSV files. So in this case, instead of having to manually go and choose the different resources, there's an agentic connector directly to TIA Portal that, like you said, with a well-documented project, is able to find the information it needs, and that context of looking at how a current project is designed and written, it can interpret those patterns and be able to build things that are more familiar uniquely to that program rather than a standard set of templates externally or something like that, if I'm kind of understanding what you meant by that.
That's correct. And so the other thing that this tool does, and to get the same effect with, say, Copilot or ChatGPT at Siemens, we use Copilot because Siemens has a specific arrangement with Microsoft where we have access to every document in the company that meets our level of access. So there are levels of access and data protection I can't go off and stumble into some sort of strategic arrangement they're trying to make with some government for, you know, access to resources or something. I can't stumble into things, but it lets me see every meeting note, every PowerPoint slide, everything that's current, future looking to a certain degree. You could get the same effect with Copilot, but Copilot can't automatically reach into CIOS and Pro documents. What they gave Engine the capability to do is go directly to the source, pull those documents. It uses search because one of the great things or not great things is that, say, Google has indexed CIOS so well, it's usually faster just to go to Google and say, hey, I'm looking for an example application for this, and it'll just hand it to you. The search inside of CIOS is not as capable, but it's not Google, right? So Google has a really good ability to do that. So while Copilot or ChatGPT can find it, it can't always pull the document, but Engine can. So it can get the actual documents and pull. So when I did the MTP example, I handed it the MTP standard to read. And so once it understood, like, oh, this is what it's supposed to do, and oh, this is how it was implemented. Oh, it uses this standard library to build like a valve and a motor and various things. It was pretty smart because it read something that would take you or I half a day or longer to even become partially familiar with. It just ripped through it and said, okay, that is the power. That is the power you're seeing in these engineering tools, is its ability to grab context so fast. And so as a user, if you're methodical about understanding why it's telling you those things, and it'll tell you, you really can learn quite a bit about a specific domain or a vertical, like a tire business or discrete manufacturing or this particular, or like aircraft. So one of my most recent assignments is to go and help somebody build a commercial jet. And so I've had to learn all about composites, how composites are made, how are they tested, and how does a robot build these things. And so I've had to expand my knowledge dramatically and used an LLM to do a lot of that.
I'm sure it would be a pressing question for people who are in that situation where it's not perfectly organized and perfectly documented right now. I'm sure there's thousands of facilities that are facing that, and they'd like to be organized, but the day-to-day operations, they just don't have time. So when you approach a situation like that, and I'm sure this is a question that could be its own discussion for days and days just by itself, but do you have any quick words of advice for somebody? You mentioned things like it can take meeting notes, it can take external rep. What is a good practice for people who are in that situation to say, what can I do today to start creating some more of that documentation without going in and changing the code, which opens up a whole can of worms in itself, but things that they can do to help give them an advantage so that the AI has the resources it needs?
Yeah. So this is the thing. I actually just did this today, and maybe this will resonate, is that we're doing some brownfield upgrades for a large company. So a lot of it is Rockwell, various things, right? But they did have, from their systems integrator, they had a good set of panel drawings. And I haven't got to the point to where I need to look at the program, because in our upgrade, we're not going to touch the PLC. We're going to upgrade some drives, some other controls things. We're going to do complete tear out some legacy equipment, right? We've got some really old stuff there. I basically gave the LLM kind of context, and I gave it the drawings. Okay. And if the drawings have even a decent representation of the machine or part of the line that you're trying to get your head around, especially if you're just doing a swap out, you can have it catalog that drawing and build you IP lists, build you connection diagrams, build you a hierarchy of connection, how things are connected just from the drawing. And if you take that and you were to add like an IO list, or you were able to actually open the PLC program, export that, LLMs can read. A lot of PLC platforms will export XML. That is one of the formats that, Step 7 supports. To you and I trying to read XML, it's just like, there's no way. LLM is no problem reading XML. It can tell you everything about that program, and something to you that looks like gibberish. So you probably have resources that are available. Drawings are great, right? And so from that drawing, I was able to basically build a conceptual data model for the whole machine. because one of the things that we're trying to do is we're trying to help them with the ability to leverage physical models in a system which originated with machines that were built 30, 40 years ago, right? They're running PLCs that may have indicated they're older than PLC 5, right? And so they're not data rich. This is just logic. In a lot of cases, these PLCs may be instructionless PLCs. And that's that code, which is basically symbols and colons and semicolons and dashes. And I know guys that can read it. Yeah, I still struggle, right? So anything that you have today, since LLMs can read almost any drawing, take a PDF directly. A lot of what I do is I will use Copilot, especially if I'm not looking at Siemens gear. For Siemens gear, I can simply shoot the barcode on the Siemens part, and it takes me to see outside of look at it. Okay. Other vendors have gotten there in various ways, but I can usually take photographs of panels, and it will tell me everything about what's in the panel, so I don't have to go do the tedious thing you and I have always had to do, is get the part number. Oh, it's this. Maybe even get the serial number to get the date range or get the manufactured on date. It does this instantly. So it is extremely valuable, right? In Siemens world, we have CIOS app that runs on Android and runs on Apple. You just walk up to the machine, you find the little square QR code, you hit it. It will tell you everything about that. It'll tell you if it's still in manufacture. It'll tell you the current firmware. If you want the firmware, you can push a button and download it to your phone. Then you have to get it onto your PC, but you can download it to your phone right there on demand, right? It really, like I said, comes down to data, but you're going to be surprised at what spending some time with an LLM that is not instructed or configured to dump its context, because you'll see in a lot of implementations companies that these LLMs will dump their context. It is one of the things they use to kind of manage data security. You also don't want to bleed over between two customers, so you have to be pretty careful. LLMs will get at memory. They get pretty smart, and they'll remember what you want, but they'll also start to get things confused unless you're very specific. And you go to the machine and you say, look, this is such and such a customer, such and such a initiative. And you always start off with that. Then you give it the bounds of its instructions, like this is the way I want you to work. And you always start this way. And conveniently, it usually uses that first line of text to actually name the conversation. So you can always look back at history and find your conversation by customer and initiative. It's just by using that methodology. This is the one I use. I think you'll see a lot of people around the internet have got, prompt examples that they use, but that's the one I've always used. It seems to work well with the LLMs I use. So it is all about data, and any notes you have are usable. Video recordings of meetings can be used. You can get notes from teams. There's a number of things that they can use to kind of get some of its initial context. And then you have to go hunt for things. But you could have an LLM give you the list or the format. So when I developed that data model for this customer, it basically told me at the end what I didn't know and left blanks in the data model for me to go find it.
The next discussion might be a little bit, might have some opinions behind it, because providing context to interpret things, really that's just, I think anybody could see how powerful that is. But then using AI to actually generate something, sometimes we say generating code, but we kind of say that out of terms of convenience. But there's far more than just lines of code. You even mentioned a project that's not even touching the PLC, but working with things like tag lists, etc. But what kind of things do you find most commonly that among engineers, who a lot of them are kind of skeptical of AI stepping in to create their code for them, but what do you find are some of the most convenient or accessible ways to be able to generate something very useful quickly that can help get started moving with AI?
Yeah, so I think one of the things that you'll find is that even in an isolated environment that the AI doesn't have access to the IDE, these LLMs are very, very good at syntax. So if you've got something that will not compile, it is very good at syntax. You can take the whole function block, if it's a structured text, hand it to it and say, hey, this thing will compile. It'll come back and tell you why. Like, you forgot the semicolon. There's an extra space there. And sometimes even the IDE system won't even flag it. It'll just say, hey, I'm going to compile, and it will point in the wrong, it'll even point in the wrong place, right? When we're talking about code, it's extremely good at like developing Python scripts or other code because it can see the whole context. It is really good at that. Just now spending some time with the tools that look at Portal, it is really, really good at syntax, right? But remember that unlike Python, which it can edit, you can run a control system, it still has to compile. It still has to be valid, right? So if you don't give the AI context to reach outside of the function that you're having it work on to reach into the safety portion of the PLC, you really can't break that, because at the end of the day, the compiler still has to compile. It has to meet all of the rules of the PLC. Remember, Python, you can change the type of a variable by changing the way it's used. So if you have a number and you treat it as a string, guess what? At that point in the process, it is now a string, and it will do various things. If it was a number, if it hasn't been assigned something, it accepts strings. It is unlikely that it will break. It will convert numbers into strings and strings into numbers and do it in a way that's convenient, or its default method, right? So it's not explicit. PLCs and control systems are very explicit, right? So you won't find yourself getting in trouble because it still has to meet the requirements of the compiler.
Well, I think anybody who's dealt with that issue of numbers versus strings, that one really stands out as a very common but very subtle syntax difference.
I think even in the Siemens world, so we now have Somatic AX, and Somatic AX is a platform that uses Visual Studio Code as the container to actually write PLC code. But ultimately, that generated code has to be compiled, and it has to be explicit enough and not break the rules of the PLC. So that PLC is your backup, even if you have external systems, right?
Keynote speakers and live sessions for Control Automation Day are brought to you by Mouser Electronics. As a leading global distributor, Mouser is your authorized source for the newest components and industrial automation products from thousands of leading brands. Well, so far we've discussed providing context for an LLM, which is obviously the very first point of importance. I don't know if we could call any step along this the most important, because without any of these, the system kind of breaks down. But providing context and then being able to actually generate a usable result, whether that's code or some other resource. But I think there's a third part that's really important to talk about, and it's the testing and verifying stage, because are there tools that allow you to not only be able to create valuable resources like code, but then also be able to check it in a way that doesn't just use the incorrect data or an incorrect assumption that it had made earlier to review and check itself? That's a very common question among people using AI, is how to generate those checks and verifications.
I'll just comment on Siemens World. In Siemens World, there is a test suite that is an add-on for KIA Portal, where you can basically design test cases. And so test cases are exactly like what you would expect to see test cases in Python, where it runs in isolation and tests certain components that are static, but at the end of the day, it checks the basic functionality of and the structure of the function block, right? Engine, the agent, is really good, and it will iterate on tests that you instructed it to make until it will compile. Right, so it will help and build tests, turn right around and run those tests and give you the result, meaning that it does it without continuous prompting. It says, okay, I need to test this. I need to test this. This is what I want to test in this function block. It'll go off and write the tests. If it has problems getting them to compile in the format that Portal expects, it'll iterate on those until it compiles. It will read the errors, make corrections to its test definition, back and forth until it will compile. Then it will run the test and give you the results. The other thing that AI is pretty good at with a tool like this is it's able to actually make an instance of function blocks and functionality and write test programs to execute them. So you have test suite with static tests, then you have the ability to create runnable instances, or in Siemens world, they call those OBs, object blocks, which are tasks and other platforms. It creates a task and runs your code in isolation, right? So it will modify your project to build these for you. And then, of course, you have the option to simply just delete those instances and that task, the containing task, when you're done with the testing, right? So using a tool to help you write those, but using the built-in tools for any generated code is really, it's required, right? It's really a good idea.
Now, when we're talking about simulation, that kind of brings up a little bit of a side discussion, but I'm curious about it anyway. The idea of like virtual PCs, software-defined PLCs, that have to be perfectly mimicking in the simulation space what is going to be seen in the physical space later. Does it take into consideration those kind of factors? I mean, my assumption is yes, because it would be a rather poor simulation if it couldn't account for what was happening in the real world. The network devices and traffic, the specifications and performance of the CPU in the real world. Does it bring in all those electrical and computer specifications and physics as well as the physical models?
Yeah. So that is one of the things that when I started to look at Siemens, more than 10 years ago, was the ability for it to simulate a PLC. And since then, it's gotten significantly more powerful. Built into Portal is the ability to call a simulation of the PLC that you are configuring. For an SL1200, since it's not the larger 1500, you use the standard PLC sim, right? And that PLC simulation lets you pull in your I/O configuration and actually set those I/O points. There's some automated functions where you can set groups of them based upon test cases, right? The real power is one of the more recent things that they released, and it's right now it's for the 1500 or for the S7 1200 G2, the next generation 1200. This PLC sim can run instead of on the simulated soft bus, it can run on your IP network, which means that you could set this PLC down in a system and do some interaction with other systems. Now, this PLC will not read remote IO racks. And the reason that's probably not such a great idea because of latency, because the thing is still running on a Windows PC. The real reason that it's probably not done is because you can simulate all of the IO with a dedicated interface, right? So you can simulate the IO, drive the points in and out. You can run the HMI. In my time in developing applications, small and large, I almost always start with the HMI. I always build the HMI so that there's always a user interface, mostly for me, so that when I get to the end of the process, I have a working system for a user to use. I look at it and spend a great amount of time thinking about what it would be like for a user to look at it as opposed to someone who would program. Does this meet their requirement? I'm always testing the system through a user interface. So in the TI Portal environment, you can simulate the PLC to PLC Sim or PLC Sim Advanced, like I said, which does TCP PLCs. You can run multiple PLCs on PLC Sim Advanced. I have a number of them running here on a second computer that I have colleagues around the country connecting to, running some of our test applications. So we treat it as a real PLC. TI Portal does not know that it's not a real PLC. It thinks it's a real PLC, loads it like a real PLC, evaluates its diagnostics like a real PLC. It does not know that it's not a real PLC. That is a cornerstone of everything that Siemens does, is simulation for most platforms. And so even companies and products, software and hardware they bought over the years, acquired and growing a portfolio, they've always added simulation right now. So I can simulate PLCs, HMIs, and today pretty much across the board, I can simulate the newer drives. I can simulate, I think, with PLC Drive Sim and Engineering, I can do the new G220. And I think I can do the S210, I think. I don't think this one does the S120 yet. It will do the S210. And I think that's something they're going to expand. And so I can test the communication from the PLC to the drive to make it do things, but I can also give this drive model its load characteristics, and it will actually run the expectation of it having the load that I've told it has. So simulation is really key, right? And so in my estimation, you always want to start with, this is the model that I do simulation. So I do read, write, predict. So I read from the PLC into a data model. I can write, if I need to, back into the PLC, but I also use mathematical models, whether it's MSIM or it's Chromes or it's one of the other packages. The SW Bleep has got a number of these packages. They're very powerful. So what I tend to do is set up the mathematical model to either take the process data and have it digital twin of what the process should be doing, right? I can have that model take idealized data, right? Validation data, and to make sure that it's going to produce the validated output. The huge win is when you can compare actuals, the read versus the predict, and let an agent run against it over time. Like, so we went from where we had to build everything and kind of trick it by going into watch tables and setting points and things and tricking the program, looking at the HMI to make sure it was within what you wanted to. Now, where we can basically build the whole thing. I mean, I have a number of PLCs here. PLC Sim Advanced is so much easier since in our team, we deal with the data up, very rarely from the machine down to the process. So we're really interested in the point in which the PLC reads the data. So inserting that data for what I do is generally not even good enough. It's preferred because I don't have to deal with the real limitations of a real PLC. A real PLC that has a wrong IO card in it is pretty unhappy. It's going to tell you about it often, if it even runs at all, right? In my world, I don't have to deal with that. Whereas if I was using a real PLC, and let's say I wanted to load my project on a real PLC, I'd have to get the hardware right. And then I would still have to put it into force mode and go in there and set points at it. Where PLC Sim and PLC Sim Advanced specifically lets me go in and directly write to those variables, those IO points directly, right? So
just to kind of make this conversation, what we're talking about here with PLC Sim, just to make sure it's clear for those who have more of a PLC hardware background, again, I'll kind of refer back to recent experience at trade shows. We see so many new strategies for control. The PLC sim and a simulated PLC in a test environment is quite different from a virtual PLC, which also is quite different from an IPC that simply is running PLC software in a container, which are all different than our vision of a traditional PLC like a classic S7 1200. So these are all different and have certain advantages for certain situations, but PLC sim is not a virtual PLC actually running a control system in any environment.
No, it's not. No, it's not. And you notice the statement I made about it. Cannot communicate with IO modules, even though it's on the IP network. My PLC sim, advanced PLCs are over running. I can connect to them. I can connect portal to them from another computer. I can have colleagues connect their portal to them over my VPN, right? So I run everything on a VPN here. A virtual PLC, in terms of Siemens, we have the V1517, we have a V1507, I think. And so where that kind of came from, again, a little bit of history lesson, is that was a request from Audi in Germany. And that's when the first virtual PLC was created. And for many years, it ran just for Audi, right? Its basis is pretty much PLC Sim Advanced, right? The way they did it, they implemented their system is they have all of their PLCs running in ESXi, right? Running in the VMware platform. They're running in containerized, they're running in containers. This data center is actually, I understand, several miles down the road from the actual plant. So they are connecting using fiber from the data center to the plant, to the IO on the shop floor, right? Just recently, and I really don't know how the Audi system is implemented, because at the time they did it, I don't think Industrial Edge existed. So today, the virtual PLC is industrial edge application. So you basically go in and you set up a industrial edge device called the IED. The IED is managed by a second computer or a cloud instance called the Industrial Edge Manager. And it is what contains your licenses. Like I say, hey, I have this IED over here. I want to put the Beast 1517 on it. I want to load some other applications I need for time syncing and some other things if I've got multiple. Anyway, I can tell the IEM, which is the Industrial Edge Manager, to deploy the VPLC to my device. So the first thing I do is I bring the device online, and it can be a physical IPC, or it can be an industrial, it can be what we call the VIED, or Virtual Industrial Edge Device, which can be a virtual machine running on a PC. But one of the recent tests we did it for a large auto manufacturer where they wanted to test, 100 of these, representative 100 of these. I guess they were planning to use a PLC per station. Not really sure of how what the architecture was going to be, but they wanted to run 100 of these, and they wanted to run up to 257 remote IO nodes, check latency, jitter, check a number of things like that. I guess the thing to note is that with the VPLC, it fundamentally functions just like the 1500 PLC. It can see IO, it can see dry, it can see anything that a 1500 can. The advantage is that if you need to move the PLC, you can move the CPU, you can move it. Within the 1500, you have the ability to connect to any number, to a specific number of IO stations, right? So it allows you to move the CPU virtually, right? This last implementation, there was compute located near the station. It wasn't centralized compute like in the Audi example and some others. It was localized compute because the IO must have already existed and there was space for the rack. PLC sim simulates PLCs. A VPLC is a true PLC. When you configure it, if it doesn't find the IO that it needs, it's going to let you know if it runs at all, right? If you haven't made special exceptions in the program or error handling in the program, it'll stop. It treats itself as a real CPU, just like you took it out of the box and stuck it in the rack. It's the same thing. It has firmware. So if you get a firmware update, of course, loading a virtual PLC's firmware is very fast, just like that. Another advantage, right? We haven't seen it yet. I'm going to speculate and say that since we have several models of virtual PLCs, I think what you're going to see is a scalable PLC. So you get a license for a PLC, a virtual PLC, and then you set its size, right? The advantage of a virtual CPU is that 100% OpEx, right? It's an expense. You have the expense of the platform to contain it, whether it's ESXi or it has to have PCI pass-through. So one of the things that makes the Siemens PLC a real-time PLC is the ability to directly connect to the PCI bus on the PC containing the virtualization platform and directly access a port. So it's guaranteed not to have its time divided amongst multiple cores. And so you also dedicate specific cores. So when you put this on an IPC, or even how I run them, typically is just on my work PC. I have a pretty good sized workstation here. And you have to allocate cores, and you have to have an allocated, dedicated NIC. It can be USB to Ethernet or whatever. In Hyper-V or VirtualBox, or they don't do PCI pass-through. So that's one of the reasons that to use the platform, and I think PCI pass-through is supported by Proxmox and VMware platforms and a few others, but you have to have PCI pass-through guaranteed time not to lose, to reduce the possibility of jitter and lag.
Well, I feel like this discussion of different types of architecture is once again one of those discussions that could probably take days to really thoroughly discuss, and the people who have had exposure and have used various types of PLCs probably understand it far better. So John, we've talked now about the contextualizing of data, generation of code and resources, and now kind of talking about the testing and simulation environment. So I really appreciate how you've kind of brought all of those three elements together, and I think all three of them are very still ambiguous and mysterious to a lot of engineers. We still hear a lot of hype about AI, and it's I think, as with any technology, it's going to take a while of using, seeing tangible examples, and hearing about how it applies to particular situations in order to become more understandable. So it's still got, I feel, a long ways to go in that regard. But I appreciate these discussions where we can get down into the weeds just a little bit and understand how it affects day-to-day operations. So I just have one quick question here before we end. Way back at the beginning, you were discussing your own path and how things became more real to you when you kind of wondered, what's the point? What's the point of the classes, the education, and then finally getting that hands-on look at electronics? And I think there's a lot of young people and newcomers into the engineering space who feel the same way, who need that real-world experience, but it's tough to get the real-world hands-on, on-the-job experience before you have that job to get the hands-on experience. If you could provide kind of one quick word of advice to those people that are getting started, what would that be?
Yeah, I think that didn't exist when I was growing up. The maker community didn't exist. It is extremely accessible today to do things that are very much like industrial automation with single board computers, breadboarding. I mean, I did breadboarding when I finally went to college in Oklahoma, but until then, it was just not something that I did, right? And so it is so much more accessible today. The things that you can acquire, it's so much cheaper per project than it used to be. There's so much of that stuff's available. I would, look at Raspberry Pis. I would look at simulated PLCs for PCs. There are a number of really great platforms out there or YouTube channels where the guys talk about a specific PLC type and general industrial automation in general. I think I would look there, but I would get into the maker community and pick a platform and just start hacking through it, right? Just look around and see, what kits are available, whether it's SparkFun or it's Adafruit or, some of these sites that dedicate themselves to these little, platforms to do that kind of stuff. And just see how much you like it, right? Because if you're messing around with Raspberry Pi and, Raspbian, which is their, version of Debian, do I like messing with Linux, right? Because you're starting to see so much more Linux in industrial automation space, right? It's very valuable. Do I like to do CAD stuff, right? Design stuff, right? It's because what we talked about, a simulation is really kind of like CAD that becomes a real world thing. It's your test and simulation guy, right? So there are so many facets to this area of automation and control. You kind of need to play around in each one of those areas, right? If you have the opportunity to go to a trade school or you have opportunity to attend one of those tech schools, go look at that and see if that's for you. If you live in a big city where you have places where you can go to work for a company that does this kind of work, as an intern, I would consider doing that. Say if you're a younger person, you're thinking about going to school, I would do some of this dabbling and playing with and make sure this is what I want to do before I jump off in it. It's so much more accessible now than it used to be. That's what I would do. Starting over again. And I'm always on the computer. I was like, I want to get that board. And I've learned a while ago that I have to be careful because I'll buy things and never mess with them. But my point is, it's so accessible. You can get more stuff than you can play with. So start small, pick a few things, kind of run it to ground and see how much you like it. And then say, okay, did I really like doing that? Or was it really aggravating when I had to get this configuration right? Because it can really drive you crazy. Or you're like, yeah, I really liked that. That was cool. And will drive someone else crazy, but you're the kind of guy who likes that level of detail. Or maybe you like to design and draw things. We want to do simulation and modular, right? That is going to be huge because at the end of the day, AI is really just like when we got Google. I don't know. Mm-hmm. I remember this vividly, right? And I can remember the things they said about search engines. Like, this is going to collapse the economy. There's no telling what this is going to do. It's a tool. It's a tool. It's an emerging tool. It's not something to be scared of. So that's where I'd start.
Yeah, I appreciate that call out to the making and hacking. I think that's where a lot of engineers get their start. And I'd probably add to throw in that trade show wild card one more time, but a lot of the big cities have trade shows that you can attend, and often it's free for attendees. And so a great place to be able to see so many real world demonstrations and products all in one building in one day is a fantastic way to make connections, network with people, and just see some of these applications. So I definitely add that to the recommendation.
Yeah, no, absolutely. And I mean, if you're at one of these big trade shows and you are around a Siemens booth, you walk up to the Siemens booth and what you'll discover is that you've got mid-career guys, you've got executives, but you usually have a lot of really young people running around there. And Siemens is really, really good at hiring people right out of college. We met a lot of really great interns. They're all about the age of my oldest, my daughter was 26, so we're all about that age. And just talk to them like, what do you do at Siemens? Or what do you do at whatever company they happen to represent? And just visit with them. And a lot of times they'll say, oh, well, I'm in marketing. And you go, well, you're an automation fan. Well, there's a lot of marketing and automation, right? A lot. I'm a project manager. What the heck is a project manager, right? Oh, you'd like to be a person who likes to organize and communicate with people. And there again, you're right in the middle of the automation world, but you're not having to deal with a configuration. You just cannot get to compile. It has to do with your preferences, right? And I agree 100%. Go to those trade shows, visit with those people. They're going to be happy to talk to you because at that point, they're not having to talk to a customer who has really hard questions, and they can talk about going to school and things like that. That's a very good suggestion. It's definitely worth doing if you have access to those, is to go to those trade shows and visit with those young people and visit with those other career professionals who've done this to kind of get a feel for what it's like. Ask them about what they make and they're presenting. They're going to be more than happy to talk to you about it. And who knows, you may be in the booth and you may meet the guy who built that PLC or built that IO module. They're out there and they can talk to you about electronic engineering, electrical engineering, computer engineering, which is a combination of electrical engineering and computer science, right? You may be a person who bridges that gap. I'm the guy who bridges project execution and programming and different technologies, just years of experience. You may find yourself one of those guys that's hard to say, what do you do? Everything. It's all good, right?
John, thank you so much for taking the time to chat today. I've really appreciated not just like hearing about your story and your experience, but also learning a little bit more about this area, which, to me has always been fairly ambiguous, but knowing that it's a very important thing to keep learning more about as technology evolves. And there's a lot of things that are certainly not going to be going away and only going to become more prevalent. So discussions like this, where we can learn the details, the how, the why, I really appreciate your time today.
Thank you, David.
Once again, our sincerest thanks to Siemens and to John for sharing his time and experience with us today. And thank you to our audience for joining us today for this keynote. We hope that you have a chance to explore the content from today's featured companies and watch the other keynote and live session events, all of which will be available on demand after today so that you can share the experience with anyone who may have been unable to join us live. Remember, the more sessions you register for today, the better your chances of winning one of our session giveaways or becoming the lucky winner of our grand prize. So thank you for joining us for this Control Automation Day 2026 presentation, and we look forward to seeing you again very soon.